There. Welcome to Knowledge Nourish. Let's get dive into our first topic, fun with primitives. Let's start with simple. We have int a is equal to 10, int b is equal to 20, int c is equal to a plus b, and let's use this out. C. So what do we expect the output should be? So it's 10 plus 20, it should be 30, right? Let's verify understanding. It's indeed 30. Now what happens if I change the data type from int to byte? So we have int byte a 10, byte b 20, int c is equal to a plus b. 10 plus 20 is 30, so we should still see 30. Okay. What happens if I change the data type of c to be byte as well? Okay, here comes the compilation error. Let's see what is it. It says it's a type mismatch. It cannot convert from int to byte. But we know a, b are byte variables. Why it's saying it's an integer? Okay, let me try with another operator. It's multiply. It's still not working. Division still not working. Subtraction still not working. So it's recognizing them as ints, right? So any operator that you use, any binary operator that you use, it will try to all these operators, the division, the subtraction, the multiplication, the subtraction, addition, all these operator will be treated as are equipped with a default data type. So we do have data types called byte, short, int, long. It's by default treat them as integer, so the output you will see is always an integer. So if we just do something like this, it will not complain. Now it says okay, this is within the bounds, and we don't care what the result of a minus b will be. I'm always going to cast it back to byte data type. This is known as type casting. Since the result of a minus b was an integer, it cannot be uh, fit into the bounds of byte, because the byte range, we know it's actually fall from minus 128 to 127. So this 10 plus 20, we know it's 30, it's within the bound. Why still it's complaining? We'll go into that as well. But integers cannot fit into the byte range, right? So byte is smaller. So this is typecasting, and this is explicit typecasting. What explicit means is we are explicitly saying to the compiler, hey, a minus b or a plus b or a multiply b could be out of the bounds. Since 10 into 20 is 200, it's out of the bound of the range minus 120 to 127. So I'm okay with it, the data loss. You can wrap it around within the range and give me back the answer. So if we just say we'll run it, it will print minus 56 because it's loop over to fall within the range. So this is the explicit typecasting, and this is also known as narrowing. So why narrowing? Because the value was big and we are trying to fit into a smaller data type. It's just like you are trying to fit in a big box into a smaller box. So that's narrowing, and it's not by default supported. It's not supported by default. What does that mean? It means like if you don't explicitly mention the type which you want to cast back to, the compiler is gonna complain. That we just saw, it says this is the type mismatch, it cannot convert from int to byte. The left hand side says byte, the right hand side computation is an integer computation. So that's why it's complaining. Now let's get into why this is an issue and why it wasn't an issue at integer level. So since the value which we are typecasting back to is int itself, a plus b might be of type byte itself, but the computation is an integer, so that's why it's allowed. And there's no left hand side and right hand side type mismatch, right? So compiler is okay, it don't give any warning here. But as soon as you jump to the narrower data type, even the same behavior will be seen for the short. So let's say we have a short a, short b, and short c. Still a into b or a plus b, a minus b will be computed into integer computation, and integer is a longer data type, or it's a bigger box than the short data type is. So that's why again the compiler complains. Now let's check one more thing. What happens if I just add final to this? We have added final short a is equal to 10, final short b is equal to 20, short c is equal to a into b. So a into b is fine, and we do know this is 200, which is within the short range. Let's take the value for byte itself, and we'll try to fit it into the byte. Now we'll see, okay, there's still an error with the final as well, but for short it was fine. And why is this? So we know 200 is out of the bounds, so let's maybe try with 10. So 10 into 10 will be 100, right? And it's still within the bounds, but as soon as we add final, it is not an issue. But if we remove the final from any of the computation, it becomes an issue. So why is that? Okay, there's something special about this final qualifiers. So we do know what does this final mean. It means it's declaring a constant, right? And what do a constant mean? It means like it cannot be changed. If it cannot be changed, that means it's same as literal itself, right? Just for the understanding sake of purpose, what do I mean by that is, so we'll say 2 is a literal, it's an integer literal. No matter what happens to 2, it will always be 2. You cannot modify it. If you say 2 plus 1, it's a new integer, it's a new integer literal, you cannot change it. So it has its own identity, it cannot be changed. That's the definition of constant or literals are. They have their own internal meaning. But so this cannot be changed, this will always be 10. And even let's say add a different value, this will always be 10, this will always be 5, this is always be 5. And this computation a into b, no matter what, since at line number 8 and line number 9 compiler knows a and b are of type final, they are never going to change. I don't treat them as variables anymore, right? So what will they do? What the compiler will do, it will, wherever that variable is referenced, so declaring a constant variable means uh, you're adding a label to a literal. So wherever that tag or wherever that literal is label is referenced, it will try to add the corresponding literal in that. So compiler won't see it a into b, it will say as 10 into 5. Okay, it says 10 into 5, 10 into 5 is 50, and we know this computation is always going to be 50. It cannot be 60, it cannot be 30, it's always going to 50. And 50, do this lie in this range? Of course it lies in this range, so why do I have to complain? But now as soon as we change it to 20, so let's change back our figures. We know 10 into 20, 10 is literal, 20 is literal. 10 into 20 is, no matter what happens in the world, it's always going to be 200, which doesn't fall into this range. And 10 into 20, this is still integer values, and this cannot be typecast back into byte unless or until specified, right? Because this is again comes to the concept of narrowing, which is explicitly not supported. So we do have conflict here. Its value is 200, it cannot fit back. So a value on the right hand side is bigger, on the operator on the left hand side is, or the handler on the left hand side is smaller. So it's a narrowing issue, and it's by default not supported. Explicitly support is there, so you need to typecast back it to byte to make it work. But once it was 5, it know it's 50, it's within the bound, it's no more a bigger box, it's the box which can fit into this size. So these are constants, and compiler will see them as just a label or a tag, and it will try to replace wherever that is being referred, so that that computation happens at the compile time itself. So 10 into 5 is 50, this happens at compile time. So if you're dealing with the constant variables, wherever those being referred, any computation related to that will be handled at the compile time itself. And why is that? If you think about it, it's always nice to pre-compute some things, right? Why do I have to remember, okay, at line number 10, when I execute this code, I'm going to say 10 multiply 10 and 5, which at compile time itself I can say, okay, the value of C will always going to be 50. So we pre-compute some of the things beforehand, and this is done at compile time itself. That's why we don't see any warning, so that runtime we have lesser computation to make. But what happens when we have byte A, byte B? We already seen that scenario, but why does this complain? Why can't compiler pre-compute this at compile time itself now? So that is actually an issue. It's not an issue. It's an understanding flaw. So we have variables, right? So what do a variable means? Let's understand that itself. So variable by its very nature, uh, they will vary over time, right? That means they can be changed. That's what the whole point of declaring variable was. Like line number 9, it was valued at 10. At line number 11, at as of now, it's still valued at 10, but compiler can't know why, because in between this can be written, right? So someone can write a is equal to 20, although it's not written, but this is completely acceptable, right? There's no complaint or no warning from the compiler side, no error from the compiler side. That is the nature of variable itself, so it can vary over time, so it cannot pre-compute it beforehand while compiling what that variable of value of a will be. It will only be known at runtime. So all the variable computations are runtime computations, when it actually get to see, okay, in the memory what that variable a points to currently at the present instant, when that code line executes, right? But if it's a final, I know I if it's a final variable a, we cannot change it. We have a error a, it's a final and you're trying to reassign that value, that is not allowed. So since it's a constant, it cannot be changed, compilers know, okay, this is never going to be changed, why can't I pre-compute it? But if it's a variable, you can write this statement, it's perfectly valid, and it cannot pre-compute it, because only at runtime it will get to know what that variable a. So this is just the initialization, right? We call it as initialization, the initial value of that variable. But if it's a final, that is the final value, you cannot change it, it's the constant value for that variable. So its initial value, you can modify it, so that is the updated value. So compiler cannot comprehend all this computation, okay, at line number 9 it was 10, at this line it's point to this, because this could be another function call which will only be get executed once you run that code. So compiler will treat the final constant as compile time computation if they are involved in any sort of mathematical operations, and if variables are involved, it's the runtime, of course. I hope the understanding is clear, and why this error is there, and why in case of final it still works. And if it's an integer, it will work because there's nothing, right hand side and left hand side both are of the same box sizes, so that's fine. Now if we just say long, it's still fine, right? The computation is still an integer, but it's a bigger box. Maybe I'll write it in the next line. So here we have something like this, and we write long. So we have this division, it's the a into b again, we have the long data type. This is known as widening, and this is by default supported. It's a default behavior, you don't need to explicitly say, hey, cast it back to the long. It's a bigger box, you want to fit a shorter value, you can definitely assign it, so you don't need to explicitly mention. So there will be no compiler error itself, because the storage space is more in long as compared to in integer, the number of bits are more. I hope this is clear. Let's look at one last scenario. We have define a variable, let's say a var is equal to 10, int b var is equal to 0, int c var is equal to a var slash b var. Okay, now let's try to print it. Let's close this so that we can execute our code. We know 10 divided by 0 is an arithmetic operation, right? It will be 0, and since these are variables, it will always going to be different values, so it can't pre-compute. Let's add final to them. So this computation 10 slash, this will be replaced by our tagged literals, right? So this a var and b var becomes a literal, it cannot be changed over time, so compiler will see it as 10 slash 0. Let's make it as 10/0. We don't need those variables anymore. Maybe we can get rid of them. Let's try to run this. It's again same error, but at this point the computation was not done at compile time. It was delegated at runtime. So why is that? So if you know, this arithmetic exception is a runtime exception, right? Even if compiler would have tried to handle that exception, it will know, okay, it will try to get it done, but it sees, okay, if it throws an error, so it makes a computation to be validated at runtime. So what do we mean by that is, let's say we'll have 10 into 50, right? So we know this is going to be 500. How do we know if it's a compile time or runtime? Is it a compile time computation or is it a runtime computation? As per the theory, we know if it's a final variable, this is never going to change. It's the literal 10 into 50 is 500. It's compiled is not complaining. That means it's been computed and it's fall within the range, so it's not complaining. uh, Now if I, let's say, add it as integer dot max value, still it's not complaining. We know now it definitely out of the range, but it's not complaining. Why? Because this operation is tied to an integer, right? So this comes with an explicit, okay, not explicit, it comes with an implicit typecasting, that no matter what, I'll add typecast back to integer. Okay, let's just run this value. It should be out of the bounds, right? So we have minus 10 here, which is fine. This is not the value we were expected. Now even if I try to do a long here, we'll still get minus 10, right? So that means 10 into max value will compute to some value, but it has an implicit cast to it, which is this int cast, right? Line number 19 and line number 20 are one and the same thing. So this is like, we don't need to explicitly mention it. Implicitly these operators have a implicit cast, which is this integer by default. How do we know it? Because we have typecast it back to the long, still the value was minus 10. That means we will have the value which is of type integer, right? We'll get back the integer as the data type, so both should be minus 10. Fine. Now if I try to pursue it to long, still I won't get the result as the dedicated result. Why? Because this again has returned me the integer, and integer we are typecast back to long, so minus 10 get typecast back to long. That doesn't what we want. So what we have to do is, maybe we'll have to change the data type itself. We know, okay, the range is not integer limited, it's a long operation. Now we'll see the actual value, which is the correct one. So back to the computation logic. So this is again computation at compile time, but then why this, how do we verify it? So let's say I have a variable called e. I'll say 10 into maybe some value 25. So how do I know if it's a compile time or if it's a runtime computation? So the question is, how do I know if this is done at compile time or runtime? So let's do one thing. Let's run it first. We know answer will be 250, but what exactly is compile time and what exactly is runtime? So if you know Java, you would have known there's a command called Java and there's a executor called Java C. Java C is Java's compiler, and the corresponding artifact that we get out of Java C is a class file. So we'll have that, and the corresponding runtime is your Java executor, right? That will execute your code, that will take in the bytecode. So why can't we check in the class file this, which is the artifact got generated? So at compile time we know there's one output, which is this dot class file get generated, right? Let's look at that.